Okay, so I'm assuming if you're watching this video that you have the basics down for equation solving, and now we're doing some more advanced stuff. So the equation I have here, what makes this one particularly challenging is the fact that I got a sine squared on one side, I got a cosine squared on the other side, so I have two different trig functions being used here. There's a way that we can get around that. However, before we start actually solving this thing, I just want to reiterate that any equation can be solved by simply looking at the graph. So if I graph the left-hand side of the equation, and then I graph the right-hand side of the equation, I'm just looking for the place where those two graphs intersect. So I've done that right here, and we're specifically looking, this particular problem, we're looking for all solutions, but if we wanted just to go from 0 to 2 pi, I can see that, so there's my left-hand side, here's the right-hand side. These things intersect at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So at least I know, kind of going into this problem, that I'm going to have 4 solutions here to deal with. Okay, so what's the strategy going to be? Well, we got to get all trig functions to be the same. I don't want to be working with a sine squared and a cosine squared if I don't have to be. So I'm going to use the fact that cosine squared is equal to 1 minus sine squared. And then I'm just going to replace cosine squared with 1 minus sine squared. Alright, now the next step, we're going to distribute and then set this thing equal to 0 and see where it takes us. So distributing the 4 through, look at this. To set this thing equal to 0 now, I'm going to subtract a 4, and then at the same time I'm going to add a 4 sine squared to both sides. Alright, so what does that give us? 4 minus 8 sine squared of x equals 0. So I've effectively taken an equation that had sine and cosine in it. I've reduced it down just to sine squared, and this is a pretty easy algebra problem at this point. So I'm going to end up getting sine squared to equal 1/2. When I take the square root of both sides, that gives me sine of x to equal plus or minus 1 over root 2. Well, I'm going to rewrite that as sine of x equals plus or minus root 2 over 2. And then these are this should be a pretty easy angle to figure out. So since it's plus or minus, it's going to be represented in all 4 quadrants. So in quadrant 1, the angle is going to be pi over 4. And since we're finding all solutions here, we're not limited to 0 to 2 pi. So it is going to be pi over 4, but we're going to add the 2 pi k. I'll explain that in a second. And then in quadrant 2, that's going to be 3 pi over 4 plus 2 pi k. In quadrant 3, we're at 5 pi over 4 plus 2 pi k. And then finally in quadrant 4, we're at 7 pi over 4 plus 2 pi k. So these would be my 4 solutions for... it's not 4 solutions. There's infinitely many solutions because I'm adding the 2 pi k here. Let's just get a visual representation of what we just did. So on this, if we look at the four quadrants here, let's just take the pi over 4. We're going to start with the pi over 4. So I know at pi over 4 is going to be a solution for this. However, why are there infinitely many solutions? Because this angle, it's a periodic function, so this angle keeps getting wrapped around. So I can go pi over 4, but I can wrap this another 2 pi. Right? If I go one more time around, I've just wrapped it 2 pi. And I can take that and I can wrap it 2 pi again. Right? I can keep coming around with this and do another 2 pi. Well, I can do this forever and ever and ever. So how do I write that algebraically? Well, we just say this is pi over 4 plus 2 pi times 1. Pi over 4 plus 2 pi times 2. Right? That's 2 times around. Pi over 4 plus 2 pi times 3. So eventually what we're getting at is pi over 4 plus 2 pi times some integer. We're going to call that integer k. Why is it an integer? Because I could go backwards around the circle as well. I don't have to keep going counterclockwise. I could go clockwise and make it a negative 1, negative 2, negative 3, and so on. So this is the way we write the solution, pi over 4 plus 2 pi k, and we say that k then must be some integer. So k is an element of the integer, of all the integers. And we have that in every single quadrant. Quadrant 1, quadrant 2, 3, and 4. So that's all of our answers for that.